are going to discuss the question from signals and systems given in GATE 2000 from the convolution concept. From GATE 2000 from convolution concept. So here given that let u of t be the step function, which of the following waveforms in figure from A to D corresponds to the convolution of u of t minus 1 with u of t minus 2. So we'll see the solution for this. So given that we need to find the convolution between u of t minus 1 with u of t minus 2. So let us consider x1 of t equals to u of t minus 1 and x2 of t equals to u of t minus 2. So that's what given here. Now we need to find the solution for convolution between these two. Now let us consider the convolution is represented with y of t equals to x1 of t convoluted with x2 of t. Then we can find that the convolution and final the y of t waveform using Laplace transform will do here. So the Laplace transform of y of t is nothing but the Laplace transform of this convolution x1 of t with x2 of t. Then we know that this is equals to x1 of s into x2 of s using convolution property equals to y of s. Then finding the x1 of s here, finding the x1 of s, that is equals to the Laplace transform of u of t minus 1, that is equals to, you know that the Laplace transform of u of t is 1 by s minus the u of t minus means that is the time shifting of u of t by one value. So this is equals to e power, using the time shifting property of the Laplace transform, this is e power minus s divided by s. Now consider the x2 of s here, that is equals to Laplace transform of u of t minus 2. This is equals to 1 by s minus e power minus 2s by s square. Now combining, this is equals to e power minus 2s by s only. Now this is e power minus 2s by s. Now taking the y of s, finding the y of s here, y of s we know that that is x1 of s into x2 of s, that is equals to 1 by s minus e power minus s by s into 1 by s minus e power minus 2s by s. So by multiplying these two we'll get 1 by s square is one term minus e power minus 2s by s square is another term minus e power minus s by s square is another term plus e power minus 3s by s square is the another term. So by applying the inverse Laplace transform for this, apply inverse Laplace transform. So here all are in terms of 1 by s squares with e power minus 2s, e power minus s, e power minus 3s. Then we know that the Laplace transform of t into u of t is 1 by s square. Then we can write this as inverse Laplace transform of 1 by s square is t into u of t. Like that, the inverse Laplace transform of e power minus ks by s square is t minus k into u of t minus k. Then using this we'll find we will write the inverse Laplace transform for the y of s here, for this expression. Now writing that, we have y of s equals to 1 by s square minus this is e power minus s by e power minus 2s by e power minus 2s by s square minus e power minus s by s square plus e power minus 3s by s square. Now by applying the inverse Laplace transform, so apply inverse Laplace transform, then it becomes y of t equals to, as above said, this is t into u of t minus this becomes t minus 2 into u of t minus 2 minus this becomes t minus 1 into u of t minus 1 plus this becomes t minus 3 into u of t minus 3. So finally, by writing in order, this is t into u of t minus t minus 1 into u of t minus 1 minus t minus 2 into u of t minus 2 plus t minus 3 into u of t minus 3. So this is the y of t we got here. Finally, this is the expression for y of t we got. Then given the answers in the form of waveforms, it is given. Now we need to draw the waveform for the obtained y of t here. So for the obtained y of t, the waveform means here t into u of t. Individually we'll draw the each and every term. So t into u of t is nothing but that is the ramp 1 at starting at t equals to 0. So this is t into u of t, it goes on like this, and minus of t minus 1 into u of t minus 1 is nothing but it will start at 1, and this we have minus and we have like this, it will start at 1 and it goes like this, t minus 1, this is t into u of t, and this is t minus 1 into u of t minus 1. Coming to the t minus 2 into u of t minus 2, this will start at 2 and it goes like this, this is t minus 2 into u of t minus 2, and t minus 3 is nothing but it will start at 3 and it goes like this, this is t minus 3 into u of t minus 3. Now we need to combine all these here. So by combining all this here, let us consider the time axis t starting at 0th position, and it is going like this, it is going towards value, and at 1 and at 1 we are subtracting this from this. So what happens, this is having the same shape and this is also having the same shape. From 1 we are subtracting this, so up to 1 we don't have anything, so that is increasing. From 1 we have the ramp signal, same ramp signal, so that's why both are subtracted. 1 from 1 0, the amplitude becomes 0 here, so it maintains like this, so after that, from that we are going to subtract the t minus 2 into u of t minus 2, so the value is goes on reduce like this. The value will goes on reduce like this, so it is started at 2, and it will go like this. And at 3, coming to the 3, see, this is going to subtract, at 3 what happens, at 3 we are adding this signal to this, then the values after this 3 like this all are subtracted, all are added with this, then the value becomes 0 here, and the value becomes 0. Then finally we'll get the shape of the y of t like this. Shape of the y of t is like this. Then we can choose the options here. So by choosing the option D is the correct here. Option D is the correct one.